Well, we've arrived at the last section in this unit, and the topic for this unit is I can factor expressions. So the warm-up for today is we're going to be simplifying the following, and hopefully this looks very familiar because we've done this before. So we're going to multiply that 8 in with both of those. So we're going to have 8x here, and then 8 times negative 5 would be negative 40. No like terms to combine or anything like that, so we're done there. Do the same type of thing here. I like drawing those lines so I don't forget anything. 21a and then plus, let's see, 35. And we'll go ahead and circle that, and we've got our answer there. Well, the fancy word for what we did above is called distributing, or using the distributive property. And there are a lot of times in math where we've got some weird sounding word, but if we know the vocabulary, it tends to make things easier. So distributing sounds pretty awful, but we're very familiar with how that works. And what we did there is we turned a multiplication problem into a combining problem. So combining, remember, we turned it into an addition problem or maybe a subtraction problem. And I'll put a little dot at the end of that. So we've got a subtraction problem here, addition problem right here. We had a multiplication problem to begin with. It was 8 times this stuff right here and 7 times this stuff right here. So we turned this one into a subtraction problem, that one into an addition problem. We can't go any further than that or simplify that at all, but what we've done is we've successfully turned it from a multiplication problem into an addition or subtraction problem with a couple of different terms there. Now this is very useful in a lot of situations. We've practiced that a whole bunch. There are many times where we're given an addition problem or a subtraction problem, okay, and we need to turn it into a multiplication problem. So we kind of need to do the opposite of what we did up above. So when we rewrite an expression as a multiplication problem, we call this factoring, okay? So this process of turning things into a multiplication problem, it actually has a name. It's called factoring. So factoring expressions allows us to find other ways to write them. So it's always good to have more than one way to write things. And often writing things in what we call factored form, so factored form, makes it easier to work with. In fact, there are some equations that we might run across that would be really, really difficult to solve if we didn't know how to factor. So it also makes it possible to solve very difficult equations that would be nearly impossible otherwise. Okay, so factoring is a really, really good skill, and we're basically going to practice what we call the first rule in factoring. And the first rule in factoring expressions with more than one term is to take out the GCF. That's why we spent so much time on that in the previous section. And we need to identify the greatest common factor, and then we need to do that. We need to pull that out. Okay, so if distributing is multiplying in, so like we did up here, we kind of multiplied that 8 in and we multiplied that 7 in. Then factoring would be the opposite of that. It would be undoing that. So the opposite of multiplying in is going to be dividing out. And it's really important that you keep that in mind because some people make some silly mistakes when they're factoring. And I'll try and show you what some of those are. So the first rule when factoring is we're going to take out the GCF. If distributing is multiplying in, then factoring is dividing out. Another one of the key ideas is we always take out the leading sign. And when we say leading sign, it's the sign at the beginning, or what the sign is of the first term. And you'll see what I mean on as we do a couple of examples. And then the last thing, and some people forget this, is if it seems like you can't take anything out, you can always take out. Now remember from greatest common factor that we did before, you can always find a factor of 1 that's common to everything. So keep those things in mind. There are those 4 key ideas. And probably the most important of those is the first rule in factoring is to take out the GCF. And that's really all we're going to practice is just taking out the greatest common factor. So we're going to factor each expression here. We've got several examples here. And then remember, we usually write the answers in alphabetical and descending order. So let's take a look at this. This one is already in alphabetical or descending order. We've got the x term first and then the constant at the end. We want to look at this and we want to figure out what can we take out of both of these. What is the greatest common factor? Well, we've got an 8 and we've got a 40, and hopefully you recognize that 8 goes into 8 and 8 goes into 40. So here's what we're doing. Remember, what we're doing here is we're dividing out. So here's how this works. We're going to take out the 8, we're going to start a set of parentheses, and then we're going to write what's left of each one of these if we divide out an 8. So I'm going to divide this one by 8, and I'm going to divide this one by 8. So 8x divided by 8, the 8's would cancel, they would make a 1, so I've got a plain old 1x there. A negative 40 divided by a positive 8, that's going to be a negative 5. So we figure out what the greatest common factor is, we pull that out front, we divide each one of these terms by that greatest common factor that we pulled out, and then we write down what's left. Now, you don't just have to take my word for it and say, oh, well, this is just what we're supposed to do, and that's how you do it. We can actually check and make sure that this is right. So what we did here is we divided out an 8. We factored this. We can double check and make sure that this is right. You're going to have problems like this on the test, so you can actually walk out on the test and know that you got a factoring problem right, because here's what you can do. We just divide it out. Well, let's multiply in. So if we multiply in, 8 times x is 8x. 8 times negative 5 is negative 40. So this gets us right back where we started. And you'll remember that a lot of math is learning how to do something and then learning how to undo it. So distributing and factoring they're opposites of each other. They're what we call inverse operations. So this is the answer on this one right here because it's in what we call factored form. It used to be just a subtraction problem, now it's a multiplication problem. All we're doing here is just rewriting it. We're making it look different. So let's take a look at the next one. We've got 21a plus 35. So take a look there. There's an a here, but there's no a there, so there's no way we can take out an a. But 21 and 35, you'll notice that they both have a 7 in common. So 7 is the GCF, so we're going to start a set of parentheses. If we divide each one of those by 7, let's see, that would be a 3 left of the 21, and we didn't touch the a at all. And then 35 divided by 7 would be 5. So this right here is the answer, and if you want to check and make sure that you got it right, all we have to do is this. 7 times 3a is 21a. 7 times 5 is 35, and there we go. We know we got that right. So let's take a look at this one, and this one has an asterisk by it for a reason, so let's see if you can figure out what's going on here. We've got 4n and we've got 2. Well, this one doesn't have an n, so we're not going to be able to take out an n. So what is the biggest number we could take out of here? Well, the biggest number we could take out that goes evenly into 2 and 4 is 2, so we're going to take out a 2. Now everybody gets this right. If we divide this one by 2, we're going to end up with a 2n. And then a lot of people will look at this and say, oh, we took out a 2, there's nothing left there, and they just leave it like that. But remember, what we're doing is we're dividing out. So we're dividing that by 2. And what is 2 divided by 2? It's a negative 1. So remember, what we did is we pulled out that common factor. Okay? So this is the right answer. Again, let's double check here. This would be 2 times 2n, that would be 4n, and 2 times negative 1, that would be negative 2. Now there's another way that you can think of these, and I'm going to do this. I'm going to change colors and I'm going to do 2 of these this way. 21 is 3 times 7 times a. 35 is 5 times 7. So what we're doing is we're pulling out anything that's common to both of those. So we've got a 7 in both of those lists. That means I'm left with a 3a. I take out the 7 and I'm left with a 5. That's another way to get the same answer. And let me do the same thing here. 2 times 2 times n minus 2 times, we've got to write that as a multiplication problem, so I'm going to write that as a 1. We've got a 2 in both lists, so let's take that out. If I took that out and that out, I'm left with a 2n, and I'm left with, don't forget the minus, and the 1. So again, there's another way where if you want to write it down in factored form, you can see how that works. So a couple of different ways to think about these, but remember, you're dividing out, so if you divide everything out, there's always a 1 left. And if you were to think that the answer was, well, let's see, I know I can take out a 2 and then there's a 2n left of the 4, but nothing left of this. If you were to multiply these together, you only get the 4n, so you don't get that negative 2 there. So you got to make sure you're careful with that. Okay, let's take a look at this one right here. This is the first one where it starts off with a negative. This is written in the correct order. We've got the y term first and then the constant at the end. So here's what we're going to do. We're going to take out a negative, and we're going to think, what's the biggest number that we can take out of a 40 and a 10? So 10 would be the biggest thing we can take out. So we are dividing by negative 10. We're dividing out a negative 10. So let's see what we're left with. So a negative divided by a negative is positive. 40 divided by 10 is 4. We didn't touch that y. What's a positive 10 divided by a negative 10? Positive divided by a negative would be negative, and 10 divided by 10 is 1. And again, you can check and make sure that you've got the right answer by distributing through. So negative 10 times 4y is negative 40y. Negative 10 times negative 1 is positive 10. So you can know that you got the right answer before you move on to the next problem. So let's take a look at this one. Notice that it's written in the correct order. We've got a negative 9k and a 9. We can definitely take out a 9, and we're going to take out a negative. So that means we took out the negative 9 and the negative 9, so we're left with a k. And what happens when we divide this by a negative 9? Well, let's see. If we divided that one by negative 9 and that one by negative 9, those cancel. That leaves us with a k. Cancels to be a 1, so we've got a k right there. And then this would be a negative 1 there also. So there's the answer. Now what I want you to take a look at is when we factor out a negative, I want you to notice on these two problems we took out a negative. Notice what happens. The first one here was negative, now it's positive. Second one was positive, now it's negative. First one was negative, now it's positive. Second one was positive, now it's negative. Taking out that negative sign changed the sign of each one of those inside. Remember, the word negative or negative means opposite. Okay? So taking out that leading sign that's negative allows us to write this in a little better fashion. We kind of like that leading term. If we've got a couple of terms together, we like that leading one to be positive. It's just a nice thing to do. In the long run, you're going to be much better off if you do that. So we're going to take out a negative on this one, but we're not going to do this division stuff. We're going to think of it this way. We're definitely going to take out a negative. Think about what number would go into both of those. That's going to be a 2. Now remember, by taking out the negative, these are going to be the opposite sign. So since they were both negative, these are going to both turn out to be positive. And if I took out a 2, I'd be left with a 2 because we're dividing by 2. Didn't touch the a. Take out a 2. Remember, taking out a 2 is not subtracting a 2. This isn't a 16. We're dividing by 2. So that's going to be a 9. And remember, said they'd both be positive. Now, this is the answer, but let me show you a different way. Let's just verify this. Negative divided by negative is a positive. 4 divided by 2 is 2, and there's the a. Negative divided by a negative is a positive, and 18 divided by 2 is 9. Okay, and then don't forget, you can always go through and do this. You can double check by distributing in, because what we're doing is we're factoring out, we're dividing out. You can multiply in to double check that you got the right answer. And multiplying negative 2 times 2a is negative 4a, and negative 2 times positive 9 is negative 18. So we got the right answer there. Okay, last little bit, and then you'll be able to do today's assignment. First thing we want to notice is this is not in the correct order, so let's go ahead and write it in the correct order. So negative 56n plus 14x plus 7. And let's see. They don't have any variables in common. We're going to be taking out a negative, and we can take out a 7. So remember what's going to happen to each one of these. We're going to divide each one of them by a negative 7. So this is going to be a positive 8n. If you divide that by a negative 7, that's going to be a negative 2x. And if you divide that by negative 7, positive 7 divided by negative 7 would be negative 1. That right there is the answer. And notice when we took out the leading sign, used to be negative, now it's positive. Used to be positive, now it's negative. Used to be positive, now it's negative. So again, pulling out that negative made each one of these terms the opposite of what it used to be. Okay? All right. X, Y, and Z. So these are in the correct order. we definitely don't have a variable that's in common, but let's stop and think. 45, 16, and 10. Gosh, is there anything that would go into all of those? No variables. Let's see, this would be like a 5 and a 9. This would be like 2s and 4s and 8s. 2 and 5. So 5 goes into both of those, but 5 won't go in there. In fact, there is nothing in common with these guys right here. So what that means is the only thing we can do is take out a 1. So this is actually about the easiest it gets. What we do is we pull out a 1, and if you divide each one of those by 1, it doesn't change any of them at all. So here's what we get. Okay, if you've got a factor, remember you can always take out a 1. That was one of those last little hints there. If it seems like you can't take anything out, you can always take out a 1. And let's see if that's helpful on this one right here. We've got a negative 13a and then plus 25. 13 is a prime number. That doesn't have anything in common with a 25. So the only thing that we can take out is a 1. In fact, we're going to take out a negative 1. We want to take out that leading sign. So that's going to change the sign of each one of these. Remember, taking out the negative makes it do the opposite of what it was. So this is going to be 13a minus 25. I'm going to circle this, and if you distribute back through, you can check and make sure that you got it right. So negative 1 times 13a, negative 13a, negative 1 times negative 25 would be positive 25. Definitely got that right there. Okay. One other thing to be aware of is you could just write it this way. That would be okay too. Whenever we've got a 1 sitting out in front as part of a multiplication problem, if you just want to have the negative there, that would be okay. But either one of those is fine for right now. All right, so if there were 2 terms to begin with, I want you to notice this. 2 terms here, 2 terms in the parentheses. 2 terms here, 2 terms in parentheses. 2 terms here, 2 terms in parentheses. 3 terms here, 3 terms in parentheses. 3 terms here, 3 terms in parentheses. So if there were 2 terms to begin with, there are going to be 2 terms in the parentheses when you're done factoring. And you can always check to see if you got the factoring problem right by multiplying back in. So multiplying back in, or the fancy word for that is distributing. All right, good luck on the assignment.